Assalamualaikum and greetings everyone. My name is Nurul Natasha binti Muhammad Rusdi. My matric number is 2018276686 and my supervisor is Mr. Zulkifli bin Osman. Welcome to my presentation. So today I'm going to present my final year project, which is a review on Moringa oleifera lemon seed extract as a novel alternative to the chemical coagulants in the wastewater treatment process. Without wasting time, let us move to the next slide. So this is the table of contents throughout the presentation. We have introduction, problem statement, objective, significance of study, literature review, and also conclusion. A brief introduction on my final year project research. Natural coagulants have gained interest in wastewater analysis due to their widespread use in conjunction with chemical coagulant. In fact, natural coagulant which derive from plant extract was discovered to be non-toxic and widely available, especially in rural regions. Natural coagulants, in contrast to chemical coagulants, are considered to be safe for the environment and living organisms due to their biodegradable features. Natural coagulants also have a number of advantages, including ease of design, low cost due to natural resource availability, lower energy consumptions during the procedure, and show a great performance in removal of organic and inorganic contaminants in wastewater. Among the species investigated, Moringa oleifera has been discovered to have an excellent adsorbent, coagulant, and flocculant capabilities, making it appropriate for wastewater treatment. The first problem is the availability of clean and safe water due to the increasing of water consumptions in recent years has urged the treatment and reuse of water. As a result of this situation, people are unable to obtain safe and clean water, which exposing them to waterborne infections. The second problem, current research has linked the utilizations of chemical coagulant in wastewater treatment to several neurological and neurotoxic issues such as Alzheimer's disease. Next, we go to the objective of this study. First, to review the properties and performance of protein fractions derived from Moringa oleifera seeds. Second, to review the applications of the coagulation flocculation process carried out by the protein fractions in Moringa oleifera seeds. And the third one is to review the efficiency of Moringa oleifera seeds as an alternative natural coagulant in wastewater treatment. The findings of this study will benefit the communities, environments, and government authorities. For communities, when natural coagulants were used in wastewater treatment instead of chemical coagulants, people were able to enjoy safe, clean water and less prone to dangerous disease caused by the chemical coagulant. In addition to being low-cost procedure, the use of natural coagulant will also produce less residual sludge to save the environment. Since natural coagulants are relatively cheap and straightforward to use, government authorities in charge of wastewater treatment will be able to cut their budget. So, for the literature review, I focus on four things, which are coagulativity of Moringa oleifera seeds as natural coagulant, the main processing step of Moringa oleifera seeds, analysis on previous study, and the research gap. In terms of natural coagulant mechanism, AA compressions, polymer bridging, charge neutralizations, and swap coagulations are the most common available. However, for plant-based coagulant, only polymer bridging and charge neutralization were the available mechanism. In order to resolve the forces that stabilize suspended solid present in wastewater, the coagulation flocculation process must be carried out in sequential step. This sequential step therefore facilitate the coalition of particles and then stimulate the formations of flux, and further sedimentation process are achieved as shown in this figure. Meanwhile, polymer bridging has been established for the coagulation of active agents present in Moringa oleifera seeds by describing the behavior of the macromolecule cationic proteins. As macromolecule with positive charges adhere to the surfaces of particles with negatively charged, the surface of charge will be neutralized and thus decrease the repulsive forces between particles, and then followed by the aggregations of particles. In addition to the charge neutralizations, the smaller particles generated will attach together, meanwhile larger particles will undergo the microflux process. The very first processing step required involves the collection of seed pod after maturation, removal of the pod and husk, and crushing of the kernel. Grinding and sieving either using a blender, mortar and pestle are grinded and sieved can generate the productions of the small particle size of Moringa oleifera seeds powder. Moreover, the extractions of Moringa oleifera seeds proteins via distilled water or saline solution are recommended as the secondary method. However, there are limitations prior to the use of the distilled water extraction method, as it increases the CO2 level in the treated water and therefore discourages the usage of distilled water. Meanwhile, protein extract by saline solution present a better coagulation properties instead of distilled water, as the presence of the salt will boost the ionic strength. This will enhance and increase in the solubility of the soluble protein and active compound, as the solubility of active compound increase and facilitate the isolation of protein. In addition, researchers have implemented a variety of ways to isolate coagulant proteins from Moringa oleifera extract. Depurification methods such as dilapidations, dialysis, centrifugations, ion exchange or lyophilizations could be used to provide biocoagulants in which the different purification method used resulted in a different productions of final coagulants. Proteins that present anti-myriad cationics and water-soluble behavior can be categorized as a better coagulant properties of Moringa oleifera seeds. The coagulating properties and protein concentrations of Moringa oleifera seeds may differ due to their growth conditions of different geographical areas, which resulted in various constituent contained in the seed. Consequently, the types of product with the various bioactive compounds of Moringa oleifera seeds depends on the solvent extractions and the extraction methods used. Moringa oleifera seeds contain various of constituents, including the isolated protein fraction. These protein fractions also indicate a highly cationic nature when the isoelectric point recorded the pH in the range of 10 to 11. Coagulant protein with a molecular weight of 6.5 kilodalton was identified as a thermoresistant proteins, and coagulant proteins with a molecular weight of 7 kilodalton was identified as an inherently disordered class of proteins. In addition, previous research has found out that albumin and globulin recorded the highest value of protein fractions. Also, the other types of protein which may be liable for the coagulation flocculation process induced by Moringa oleifera seeds were identified as shown in this table. Previous study has stated that excellent coagulation properties which can fully eliminate the water turbidity must convey less than 36 kilodalton of their molecular weight. Several kinds of research on Moringa oleifera seed as coagulant aid in wastewater treatment has been summarized from 2016 to 2021. Physical forms of Moringa oleifera seed, coagulant dosage required, and percentage of turbidity removal of different types of wastewater are among the parameters discovered in this research. All of studies summarized has shown the use of DFAT Moringa oleifera seeds powder in their research. A study by Mohammed Noor in 2021 reported the performance of Moringa oleifera seed in terms of coagulation flocculation on palm oil mill effluent, in which the result discovered that by applying 3 grams per liter of Moringa oleifera dosage could enhance the reductions in turbidity by 80%. Moreover, Gautam and Saini in 2020 conducted a research on bentonite clay-based drilling slurry in which the findings achieved 99.55% of turbidity removal with 10 grams per liter of dosage. The research by Rosmawani in 2018 on raw public market wastewater showed 86.24% of turbidity removal by applying 180 mg per liter of dosage. Another study by Baulach in 2018 highlighted the effectiveness of Moringa oleifera seed in terms of turbidity in treating peppermill wastewater. Interestingly, 150 mg per liter of dosage can reduce turbidity by 96.02%. The aim of Pereira's study in 2017 was to explore the use of Moringa oleifera in treating surface water. By applying 50 mg per liter of dosage, low turbidity wastewater achieved 60% of turbidity removal, meanwhile 89% for high turbidity wastewater. Hendrawati in 2016 conducted a study to assess the cost-effectiveness of Moringa oleifera seed in treating both groundwater and textile wastewater. As for groundwater, 80 mg per liter of coagulant dosage successful to remove the turbidity by 97.5%, meanwhile for textile wastewater, 98.6% of turbidity removal by applying 10 grams per liter of dosage. So here is the list of research gaps that I managed to identify throughout this study. First, how will natural coagulant replace chemical coagulants in the coagulation process? Second, what are the best parameters to use to assess the efficiency of Moringa oleifera seeds in wastewater purification? Third, is it necessary for all extractions of Moringa oleifera seeds in wastewater treatment? Fourth, which protein fractions in Moringa oleifera seeds are responsible for the coagulation and flocculation process? And the last one, what are the best conditions for Moringa oleifera seeds to be applied in the wastewater treatment? As a conclusion, all the previous studies have concluded that Moringa oleifera seed has an outstanding coagulant properties and is acceptable for water and wastewater treatment. Due to its low cost of push and widespread availability, Moringa oleifera as a natural source may be beneficial to stakeholders in both developed and developing countries with limited technology. The following recommendation might provide a better performance of Moringa oleifera seed in wastewater treatment. First, extensive research into the factors that influence the coagulation flocculation process should be conducted. Second, Oil extractions of Moringa aloe vera seed should be widely implemented as the fat seeds powder will present the best effluent reduction. And the last one, non-synthetic substances in smaller amounts are recommended for the optimization.